Hello everyone, in today's topic, we are going to talk about application of Pythagorean Theorem. The Pythagorean Theorem has many applications in science, arts, architecture, and engineering. So if the hypotenuse is missing, we are going to use c squared is equal to a squared plus b squared. And when one of the legs is missing, a squared is equal to c squared minus b squared. So let us have example number 1. A tree is struck by lightning and has divided into two parts. The first part is 3.3 meters and the second part is stretched 5.6 meters across ground as shown in the diagram. So what is the original height of the tree? In order to get the original height of the tree, we are going to solve first side x and then we are going to add it to 3.3 meters. To solve for x, we are going to use the formula c squared is equal to a squared plus b squared. And then we are going to substitute the values 5.6 squared plus 3.3 squared. 5.6 squared is equal to 31.36 while 3.3 squared is equal to 10.89. Adding it up, it is equal to 42.25. And then get the square root, it is 6.5. So therefore, side x is 6.5, and then to get the original height of the tree, we are going to add 6.5 meters plus 3.3 meters is equal to 9.8 meters. So the original height of the tree is equal to 9.8 meters. Now let us have example number 2. The ladder whose base is 9 feet from the front of a house reaches to a window sill 40 feet above the ground. What is the length of the ladder? So in here, we are going to compute for side x. And to compute for side x, we are going to use the formula c squared is equal to a squared plus b squared. Substituting the measurement or the length of the legs. So we have 9 squared plus 40 squared. So 9 squared is equal to 81. 40 squared is equal to 1,600. Adding it up, it is equal to 1,681. And getting the square root of 1,681, it is equal to 41. So therefore, the length of the ladder is 41 feet. Now let us have example number 3. A pirate ship sails 33 kilometers due south and then 56 kilometers due west. So how far is it from its starting point? So we are going to compute for side x. To compute for side x, we are going to use c squared is equal to a squared plus b squared since we are looking for the hypotenuse. Substituting the values, so we get 33 squared plus 56 squared. So 33 squared is equal to 1,089. 56 squared is equal to 3,136. Adding it up, it is equal to 4,225. And the square root of 4,225, it is equal to 65. So therefore, side x or the distance from the end point to the starting point of the ship is equal to 65 kilometers. Now let us have example number 4. From P, you go west 25 meters, then north 60 meters, then east 80 meters, finally south 12 meters. How far are you from point P? So in here, I will gonna draw the side, this side, and this side measures 60 minus 12, which is equal to 48. And another side, this one, it measures 80 minus 25, which is 55. Then we are going to compute for the broken line. So it is the distance from the starting point to the end point. So from here, we are going to compute for side x. To compute for side x, since it is the hypotenuse, we are going to use c squared is equal to a squared plus b squared. So from here, substituting the values, so we get 48 squared plus 55 squared. 48 squared is equal to 2,304, while 55 squared is equal to 3,025. Adding it up, it is equal to 5,325 5,329. Square root of 5,329 is equal to 73. So therefore, the distance from the end point to the starting point is equal to 73 meters. Let us have example number 5. Two cars starting from the same point head off in different directions. One travels due west for 10 kilometers, and the other car travels due south for 15 kilometers. How far apart are the two cars when have both come to a stop? So from here, we are going to solve for side x. And to solve for side x, we are going to have c squared is equal to 10 squared plus 15 squared since we are computing for the hypotenuse. 10 squared is equal to 100, 15 squared is equal to 225, 100 plus 225, it is equal to 325. And the square root of 325, it is square root of 25 times 13. Since 325 is not a perfect square, we are going to have one of the factors which is a perfect square. So 25 is a perfect square and the square root of 25 is 5. So we have 5 square root of 13. If we are going to simplify it further, it is equal to 18.03. So therefore, the distance between the two cars, when they have their stop already, it is 18.03 kilometers. So let us have example number 6. The top of the rectangular box has red ribbon crossing it diagonally. If the top of the box measures 15 centimeters by 20 centimeters, what is the length of the red ribbon? In here, at the top of it, we have a red ribbon. So the length of the red ribbon we are going to solve. And the dimensions of the rectangular space at the top are 15 centimeters by 20 centimeters. So from here, we are going to solve for side x. To solve for side x, since we are computing for the hypotenuse, we are going to use c squared is equal to a squared plus b squared. Substituting the values for your a and b, we have 15 squared plus 20 squared is equal to 225 plus 400. Adding it up, it is equal to 625. And the square root of 625, it is equal to 25. So therefore, the length of the ribbon is equal to 25 centimeters. Now let us have the last example. A rectangular field 80 meters long is said to be fenced with the wire. If the diagonal of the field is 100 meters long, we are going to find A, find the width of the field, B, find the length of wire needed to completely surround the field. So in here, we are going to solve first for the width before we are going to solve for the length of the wire. To solve for the width, we are going to have a squared is equal to c squared minus b squared. Why? Because one of the legs is missing, so we are going to subtract. So the diagonal is c and the length is b. Substituting it, we have 100 squared minus 80 squared. 100 squared is equal to 10,000 while 80 squared is equal to 6,400. Subtracting it, it is equal to 3,600 and getting the square root, it is equal to 60. So therefore, the width is equal to 60 meters. Now that we have the width, we are going to solve for the length of the wire. To solve for the length of the wire needed to completely surround the field, we are going to have the concept of the perimeter of a rectangle. And to have the perimeter of the rectangle, we are going to have the formula 2 length plus 2 width. Since the length is given already, so 80 meters, and the width, we already solved it, it is 60. So we have 2 times 80 meters plus 2 times 60 meters. So 2 times 80 is 160 and 2 times 60 is 120. Adding it up, it is equal to 280 meters. There's another way to compute for the perimeter of a rectangle. You can always add all the lengths of the sides of the rectangle. So 80 plus 60 plus 80 plus 60, the same answer, 280 meters. So please do your worksheet 1 in the Google Classroom. So this time you are going to have the Wiser Interactive Worksheet because last week you already did exercise 1A and 1B in your book. So that's it for now. Thank you for watching. See you again next time. Bye.